What if the greatest forces reshaping human civilization aren't viral technologies, aren't political speeches, aren't even discoveries in space, but concrete, steel, water, glass, and mathematics? What if the true revolution of our time is happening quietly, beneath our feet, above our heads, and across the landscapes we cross every day? You drive across it, you live inside it, you depend on it, and most of the time, you don't even see it. Across the planet, mega projects are redefining the limits of geography, climate, and human ambition. They are not futuristic concepts. They are not experimental prototypes. They are working right now. And once the impossible becomes infrastructure, the world changes permanently. Rivers controlled, landscapes redefined. On China's Yellow River stands the Xiaolangdi Dam. The Yellow River is often called China's sorrow. For centuries, its floods devastated communities. But water wasn't the only threat. Sediment was. The river carries one of the heaviest sediment loads on Earth. Over time, that sediment raises the riverbed, increasing flood risk for millions downstream. So engineers built more than a hydroelectric station, they built a sediment control system. Standing 154 meters high and producing nearly 1,836 megawatts of electricity, Xiaolangdi regulates both power and protection. Massive low-level outlets release controlled torrents that flush accumulated silt downstream during carefully timed operations. Instead of fighting the river, the dam works with it. It transforms chaos into cycle, flood into flow, threat into system. But China's ambition does not stop at one river. The South-North Water Transfer Project is one of the largest water diversion projects ever attempted. Northern China faces chronic water shortages. Southern regions hold surplus supply. The solution: move the water. Thousands of kilometers of canals, tunnels, and pumping stations redirect water from the Yangtze River basin toward the north, including Beijing. This isn't a single structure. It's a national-scale hydrological redesign. Water is no longer confined by watershed boundaries. Scarcity becomes logistics. Engineering in motion. In Scotland, engineering becomes kinetic art at the Falkirk Wheel. Before 2002, boats navigating between two canals separated by 24 meters relied on a staircase of locks. Slow, labor-intensive. Engineers replaced them with a rotating boat lift. Two water-filled caissons rotate 180 degrees, lifting vessels effortlessly. The genius lies in balance. Each basin weighs the same, whether or not a boat is inside. A vessel displaces its own weight in water, maintaining equilibrium. The wheel doesn't fight gravity. It dances with physics. Massive steel, gentle motion. Across Alaska, flexibility ensures survival in the Trans-Alaska Pipeline System. Stretching over 800 miles, it carries crude oil from Prudhoe Bay to the southern port of Valdez. But Alaska moves, permafrost thaws, earthquakes shift ground, temperatures swing dramatically. So engineers elevated large sections of the pipeline. It rests on supports designed to flex and absorb movement. Instead of resisting the earth, it adapts to it. Rigid systems fail. Responsive systems endure. Cutting through the earth. In Greece, ambition carved through stone to create the Corinth Canal. For centuries, ships detoured around the Peloponnese Peninsula. The canal, completed in 1893, created a 6.3-kilometer shortcut between two seas. But the canal is narrow. Steep limestone walls rise on either side, vulnerable to landslides and erosion. It represents 19th century boldness, an era willing to slice through geology itself. Progress, at times, is decisive. In Wales, water appears suspended in air at the Pont-Sylt Aqueduct. Completed in 1805, it carries the Llangollen Canal 38 meters above the River Dee. A cast-iron trough reduces weight while preserving strength. Slender stone piers support the structure with quiet confidence. Boats glide across open sky. 2 centuries later, it still functions. Durability is the ultimate measure of engineering. Height becomes routine. In southern France, the Millau Viaduct stretches across the Tarn Valley like a line drawn in air. At its tallest point, 343 meters above ground, it surpasses the Eiffel Tower in height. Instead of forcing drivers down winding valley roads, the bridge keeps traffic elevated and direct. The structure was assembled incrementally from both ends, sliding deck sections outward over open air until they met in perfect alignment. Distance shrank. Time collapsed. In Dubai, vertical ambition culminates in the Burj Khalifa. At 828 meters, it redefined skyscraper possibility. Its tapered, spiraling setbacks reduce wind forces. High-performance concrete supports extreme height. Inside, it functions as a vertical city: residences, offices, hospitality. Elevators travel at astonishing speeds. Engineering pushes upward, and the skyline follows. Building land from water. Off the coast of Dubai lies Palm Jumeirah, an artificial archipelago shaped like a palm tree. 17 fronds, an 11-kilometer crescent breakwater. Millions of cubic meters of dredged sand were compacted to create stable ground. But engineering doesn't end with construction. Slowed water circulation required design adjustments. Openings were introduced into the breakwater to restore tidal flow. Land built from sea demands perpetual management. In Singapore, density becomes design at Marina Bay Sands. 3 towers support a rooftop sky park that appears to float 200 meters above ground. The integrated complex includes hotels, retail, convention space, and entertainment, all stacked vertically. Instead of spreading outward, the city builds upward. Urban compression replaces sprawl. Framing 2 eras of a city stands Dubai Frame, a massive rectangular structure. One side reveals old neighborhoods. The other captures futuristic skyscrapers. It doesn't dominate, it contextualizes. Architecture becomes narrative. The pattern behind the projects. Across deserts, highways stabilize shifting sand. Across mountains, tunnels erase isolation. Across oceans, bridges reduce separation. Across underground caverns, infrastructure regulates temperature and pressure. Across cities, airports integrate waterfalls and forests to cool and calm travelers. Each megaproject answers the same essential question: how do we convert obstacle into system? Wind becomes engineering data. Water becomes supply chain. Height becomes structure. Distance becomes efficiency. Megaprojects are not just large, they are coordinated. They require geologists, environmental scientists, material engineers, mathematicians, policymakers, financiers. They require patience measured in decades. They reshape economies. They redirect migration. They influence culture. When a bridge shortens travel time, commerce accelerates. When water becomes reliable, cities expand. When electricity stabilizes, industry grows. Infrastructure is silent, but transformative. Risk and responsibility. Megaprojects also carry consequence. Environmental disruption, financial burden, maintenance complexity. Every large system introduces trade-offs. A dam generates power, but alters ecosystems. An artificial island expands housing, but shifts marine flow. A pipeline delivers energy, but requires constant monitoring. Engineering does not eliminate risk, it manages it. The scale increases the stakes, and the world watches. The psychological shift. When humans build at this scale, perception changes. Height once feared becomes normal. Distance once daunting becomes routine. Water once unpredictable becomes controlled. Each completed project raises the baseline of expectation. Children grow up seeing skyscrapers touch clouds and assume it is natural. Drivers cross massive bridges and rarely consider the forces balanced beneath them. What was once headline-making becomes background, and that normalization fuels the next leap. The future under construction. Somewhere right now, engineers are mapping new coastlines, designing carbon-neutral cities, planning floating communities, studying how to protect coastal regions from rising seas, testing materials that self-heal, calculating structures that adapt to climate extremes. Mega projects of the future may not just resist the environment, they may collaborate with it. Cities powered by renewable grids, bridges built from carbon fiber composites, water systems recycling every drop, infrastructure that learns. Because throughout history, civilization advances not only through ideas, but through structures, through roads, through aqueducts, through dams, through towers, through networks. The pyramids declared permanence. Roman aqueducts declared mastery of water. Industrial railways declared mobility. Modern megaprojects declare integration. The world is no longer shaped only by natural geography. It is shaped by engineered geography. You are living inside the most ambitious construction era in human history. A time when deserts host skyscrapers, when mountains are tunneled, when rivers are redirected, when islands are manufactured, when height no longer intimidates, when motion is balanced by physics, when scale becomes routine. The next time you cross a bridge, look down. The next time you see a skyline, look up. The next time you turn on a faucet, pause. Behind each convenience lies calculation. Behind each smooth surface lies decades of design. Mega projects are not monuments to ego. They are monuments to coordination, to planning, to persistence. They represent humanity's refusal to accept limitation. And once something once labeled impossible becomes infrastructure, the definition of impossible changes. The boundary shifts. The horizon moves, because someone, somewhere, is already looking at the next river, the next canyon, the next desert, the next coastline, and asking not, can we, but how?